Okay, welcome back to Karnaugh maps. I know the previous lecture was long. It was 43 minutes long. I didn't even realize how much I talked. Um, oh well, what can you do, right? The problem of this is you have to understand the basic concepts of the map in order to do anything else. It's like a very solid foundation for everything else. All the microprocessor designs, all the uh, basic gates circuitry will be based on a Karnaugh. Okay, so that's why I was very detailed. But now today's lesson will be much shorter, and we'll fly through the examples. I will show you the example of two and three variable K-maps and solutions. Okay. All right. So let's look at the picture of Mr. Karnaugh. Mr. Karnaugh again, and let's look at the following. Okay, variable fields. We didn't discuss the variable fields yet, but they are incredibly important. Okay, look at this. What we used to do is we did the following. The left side of the map, we used to transfer the function and look at how to group the mean terms and how many groups we created and how big of the groups they were. And then we had to go on the right side to figure out what are the terms that all these groups generate. Now, guess what? We don't need the right side. We don't need to see that. We don't need to look at which variables change in a group. Okay? All we need is the variable fields. So let's look at the variable fields. Variable field x is mean term 2 and 3, so it means it's a lower row. It's a bottom row. Look at this. You see this x right here? That's the bottom row. X prime is the top row. So variable field x is right here. That means that the variable field x prime is right here. Oops. Let me erase this. All right. So variable field x prime is right here. X prime. The variable field x prime. Where x primes are right here. X primes are right here. And guess what? Variable field y prime will be here. That's where y primes are here. Those y primes right here. That's where they are. All right. The problem is when you have only two variable map, you can deal with those prime fields. But if you have a three variable maps or four variable maps, so the description of the fields will be way too confusing. So we're keeping those descriptions of variable fields simple. Only unprimed variables will be described. Okay, and let's erase this. All unprimed variables. We know that x prime is this. So everything but x. So x, if x field is here, x prime field is there. All right, simple enough. Now let's look at the variable field. So let's go back to variable function. Bottom row, variable field x. Second column, variable field y. Now let's look at this variable function. Bottom row, variable x. Last two columns, variable y. Middle two columns, variable z. Look at this, variable z. That's the field z, middle two columns. Field y, see? Last two columns. And field x, all x's are at the bottom. X primes are at the top. All right, so now how do we use this? We can eliminate this map. Eliminate this. Oh, here we go. I wonder if I can do this. Let me go to the okay. Here we go. We do not need those. We do not need those. We can do better. Much simpler to just look at those variable fields. All right, now let's look at the example. So the first thing you do, this is a typical, I'll show you solution in its entirety. So this is a typical example. We have a function that is denoted as mean terms, the sum of mean terms 0, 1, 3. The first thing you do is you go around the variable fields. Okay, so go around the map, put the variable fields on, and then transfer the function. So don't forget, the variable field x is always bottom, y is last two, columns, and z is middle two columns. Here we go. And now we transferred it from the function to the map. 0, 1, and 3. 0, 1, and 3. All right, the rest of them are zeros. We don't have them. Hello. Good. Okay, now we can have the following. We can have either three singles that will create three terms of the function, or we can have a pair and a single this way, or pair and a single this way. We cannot have a triple. Triples, guess what? They don't exist. The group triple doesn't exist. The groups that exist are single, pair, one, octet, and then it continues forward. Guess what? These groups have one thing in common. Pair is just one field. Single is one field. Pair is two fields. Quad is four fields. Octet is 8 fields. So you see 1, 2, 4, 8. Though this is the only groups that can exist. So next group will be 16. And the group after it will be 32. We'll look at those. But we need more bigger maps. Okay, so looks like if the group 3 of threes doesn't exist, we have to use the following. We can do this. And we can do the single, or we can reuse the min term 1 and do a bigger group. Because the name of the game for K-maps are the least amount of groups and the biggest groups possible. That's what you have to create. So for this map, the least amount of groups are 2. You cannot make it with one group of 1. You cannot cover those. And the biggest groups are 2 pairs. You can have a pair and a single, but this is not optimum. The optimum is 2 pairs. All right, so let's look at this. First, this pair right here, min term 0, min term 1, this pair is entirely within x prime. See, this is x prime right here, x prime, and this group is entirely within y prime, where y prime is, and this group is partially within z prime, partially within z prime, partially within z. If the group is partially within the variable z prime and partially within variable z, that variable is gone. That means this is what we call, you see this is the border of z variable field. Okay, if the group jumps the border right here, jumps the border from z prime to z, that means this variable is eliminated. If the group is entirely within the field, that means this variable stands. So looks like this group is within field x prime and y prime. Z is eliminated because it's a pair, so the one of the variables has to be eliminated, and that is z. All right, so it's x prime, y prime, x prime, y prime, and plus we have another group right here. This group. Let's look at this. This group again is within x prime. You see this x prime field is right here, and this group is entirely within x prime, and this group is entirely within field z. You see this is field z. So this is entirely within x prime and z. That means this is what it's going to be, x prime z. All right, this group jumps variable y right here, right here, right here. So this group jumps from y to y prime. You see, this is field y, this is field y prime, and so it changes from y to y prime. That means this variable will be gone, y will be gone. So this is, we covered all the midterms, we created the groups, we read what these groups represent algebraically, and this is a solution. Okay, so min term 0, 1, 3 can be expressed as x prime y prime plus x prime z. Now we are ready to get into our basic gates and build this diagram. Build this diagram with the way basic gates is tested. All right, let's look at the next example. 0, 2, 4, 5. All right, I'm going to go faster now. Okay, so first variable fields x bottom row, y, last two columns, z, middle columns. Okay, now let's transfer this. Let's go black here. Let's make this a black ink. 0, 2, 4, and 5. All right. Got it. Now, okay, we can have a bad idea to cover all these meters and good idea. Bad idea is the following. When you start covering the midterms and you do this. Oh, I have a pair. 1. Now I'm going to cover midterm 5 with the second pair. I'm going to reuse midterm 4. And I'm going to cover midterm 2 as not as a single, but as a wrap-around pair. I'm going to go this way, right? Why is this changing? I'm going to go this way. So I have 3 pairs. There's a better way. Okay, so let's get rid of those pairs. And the better way is the following. If you can start covering these pairs with M4 and M5, it will be 1 pair, and then M0 and M2 will be second pair. So instead of 3 pairs, we have 2 pairs. And all the midterms will be covered. All right, so let's read what kind of function it is. So midterm 0, 4 to 5 will be this group, midterm 0 and 2. This is wraparound pair. This group is entirely within Z prime. You see this Z prime right here, and this Z prime is within Z prime. This group doesn't exist in Z because Z is here. So this group is Z prime times entirely within X prime right here because X prime is the parallel. So it looks like this is X prime Z prime. X prime Z prime. Now next group will be this group. This group is entirely within X field and entirely within Y prime field. This field Y, and this group is outside of field Y. This group is in the field. Okay, so it looks like this group is will generate the following term: X Y prime. Now let's write it up: X Y prime, and that's the answer. Okay, so that's very simple. Now let's look at the next group. 0, 2, 3, 5, 6. All right. Fields, field X, field Y, and field Z. Let's transfer the function into the map. 0, 2, 3, 5, 6. All right. Looks like this is a little bit more complex. Function is scattered a little bit. It is definitely not a nicely distributed function. All right, so now we have to figure out the following. What are the biggest, create the biggest groups and create the least amount of groups. All right, so I think we should go the following. Definitely this midterm 0 can be attached to midterm 2. No quads. That's what I always look at. Are there any quads? There are no quads. There's no 4 adjacent midterms that create nice quad. There are none of it. So this is the first group. So let's this group, let's write it up right away. This group is, that's crazy, changes color by itself. This group is X prime, Z prime, X prime. Okay, because this group exists in field X prime and in field Z prime. Field Y, this group jumps from Y. Midterm 2 is in Y, and midterm 0 is in Y prime. So Y is eliminated. All right, now we have a next group. Next group will be M3. M3 is not a single. It can be attached to M2. We can reuse M2. All right, so this group will generate the following term. Y, definitely entirely within Y, entirely within X prime, so X prime Y. And now we have the third term, M6. It can be a single, but we can do better. We can reuse M2 again, right here, okay? And write it up as Y Z prime. So this group, this vertical pair generates Y times Z prime. It's entirely within Y, entirely within Z prime. And now I have this M5, this poor M5 cannot be attached to M0 because it's diagonal, cannot be attached to M3, and it's just a single. All right, so let's write it up. This is a single, and M5 is, that means this M5 single doesn't eliminate any variables. That means this group is, M5 is entirely within X, Y prime, Z. That's mean term 5. X, Y prime, Z is mean term 5. All right, so we got it. This, see this term? This cannot be simplified. I dare you again. Try to simplify this. Try to cross anything out, factor something out, cross anything out. Cannot be simplified. You know why? I know, because I drawn the simplest solution. 3 pairs and 1 single. Pair, second pair, third pair, and 1 single. This is the best grouping for this map. And if I use the best grouping, that means this because the best grouping gives you the simplest solution. So the solution doesn't look that simple, but look at this. We have 1, 2, 3, 4, 5 mean terms, and now we have 4 groups only. And some groups eliminated some variables. In this 3 terms eliminated variables. That means that your gate diagram will be much. All right, then let's see what we have here. Let's do the following. Let's transfer this. Let's transfer this function right here. So the map and see if this function has to be that long. All right, variable x, variable y, and variable z. All right, let's transfer. 1 is 0 is in, 1 is in, 2 is in, 3, 4 is present, 5, 6, and 7. Okay, now this is interesting map. So let's look at this. Now the second step is to group them in the biggest possible groups. I don't see an octet. Octet will be all 8, but min term 3 is 0, so you cannot put an octet. You cannot do this. Okay, octet. No, because you cannot cover zeros with the groups. Okay, so octet is not a good idea. All right, but so the next group, biggest group, is a quad. I have a quad right here. Look at this. I have my quad, and this quad eliminates 2 variables. So only 1 variable is left from this group, and this is variable y prime. This group is entirely in y prime. It jumps x right here, jumps x, and jumps z right here. You see, jumps z. It goes from z to z prime and goes from x to x prime. Okay, so that means x and y are gone. So this one, x and y, no, it doesn't jump y, it jumps z. So this group is in y prime. There we go. Now we have 3 more meters to cover: 2, 6, and 7. How do we cover them to create the biggest groups? We're going to do the following. Look at this. This mean terms 7 and 6 can be attached to 4 and 5 to create a quad. That means this mean term 6 and 7 will be covered by the quad, not the pair. Pair is the smaller than quad. You always aim at the bigger group. So this group is entirely within X. So this 4 mean terms will generate term X. All right, and now we have a mean term 2. our poor lonely min term 2. This is not a single. You can cover it better. You can cover it, you can attach it to min term 6 and have a pair. Guess what? You can do better. M2 is not a single. M2 is not a pair. It's a quad. It's wraparound quad. So you can do the following. Right here, you see this? Min term 2, min term 6, 0, and 4. That's where it's wraparound pair. And this wraparound quad. And this quad is entirely within Z prime. Exists within Z prime. Okay. Field Z is right here. This quad is outside of the times it's okay. All right, so this entire let's count how many terms do we have. Min term 0, 1 term, 2, 3, 4, 5, 6, 7 terms. Each min term is 3 variable term, so we have 7 3 variable terms. Map allowed us to simplify this to 3 1 variable terms. This one is very easy to build the basic gates. This one difficult. This one, that's why we're using map. Okay, that'll be all for tomorrow. For today. Tomorrow we're going to continue with our example.